Hello everyone. We are looking at phase 3, chapter complex number, exercise 1. Presently we are at exercise question number 11. Question number 11. The question, let's go through the question. 1 plus omega square, let them be the cube root of unity. And we have to find the roots of the following equation, x minus 1 whole plus 8 is equal to 0. All right. Sometimes it's a very common query from from children that, ma'am, why do we only study cube root of unity, not any other number? So I think this question will answer that, because we can always manipulate other numbers and into cube root of unity. We can always express other numbers into that. So just let's go through it. So x minus 1 whole cube is equal to minus 8, and x minus 1 cube minus 8. Now, on the right-hand side, if we see minus 8, we can write it as 8 1 by 3 minus 1 1 by 3. Now, because it is minus 1, cube root of minus 1, we know the answer is going to be minus. So we can factor that minus out and it becomes 1 minus x is equal to cube root of 8. We can take as 2, only the real part, because the complex part is going to be covered by this. And this is nothing but 1 by 3. Now, 1 by 3, we know this is cube root of unity. We know the answer is going to be. So, this side, 1 minus x, the roots of this is going to be 2 omega and 2 omega square. So 1 minus x is going to be 2 omega and 2 omega square. That implies that x is going to be, we can take individually, like 1 minus x is equal to 2. So x is equal to minus 1. 1 minus x is equal to 2 omega. Then x is equal to 1 minus 2 omega. And 1 minus x is equal to 2 omega square. So x is equal to 1 minus 2 omega square. So in terms of omega and omega square, our answer is going to be this. My omega is looking like w, but I think you get the answer. So it is minus 1, 1 minus 2, and 1 minus 2 omega square. So the final answer is okay. But the concept here is this. We proceed as we do, and then we try to incorporate cube root of unity. Take everything, the real part and the complex part is only covered by the cube root of unity. And then we go ahead as we solve any other equation. That's it. Thank you.